Hey there, guys. I hope everything is going well for you right now. We're going to take a look at methods again right now. We've done iteration using loops. Now we're going to take a look at iteration versus recursion. So you might remember a while ago, we were first learning about iteration, learning about loops. We did a simple program, right? We said 3 times 4. And what is 3 times 4? It's really just 3 plus 3 plus 3 plus 3. And we built a program that did that, right? So what I have here is I have this program right now. And if you look down here in my main, and I'll show you what I have laid out, and then we're going to come back to the other part. So I got a scanner set up. I got a looping. I'm running a main menu. So what's in my main menu? Right now I have multiplication, powers, factorial, something that's going to come soon, then exit, okay? So we're going to do multiplication two different ways. So we come down here in case one, when they choose multiplication, they're going to run this method called input number, where I'm just going to pass in number one and number two, and I'm going to extract num1 and num2 from it, right? So this is very similar to the input dimensions that we did before for the rectangles, right? So I'm going to actually I set my number to -1, and I want it to be a non-negative number. So if it's less than 0, I'm not going to accept it. Or if it's less than 0, I'm going to throw up a message. Or here what I'm looking for. If it's less than 0, I'm going to throw an error out at them. Sorry, that didn't make much sense. But anyway, so that's our input number method. And later on, I'm going to use it, like they're going to put in number 1 and then number 2. And later on, I might put in base, next exponent, and things like that. All right, so if I come back down here, after I've taken the two numbers, I'm going to say iterative, num1, let's say it's 3 times 4, and then I'm going to run this method called multiplication iterative that's going to take 3 and 4 and generate 12 for me. Then I'm going to do it recursively. I'm going to take 3 times 4 and I'm going to generate it recursively. So I'm going to go ahead and I'll run this right now. And I actually, like I said, I have the iterative version running right now. Let me minimize that. And so I go ahead and I type in number 1, and it wants the number 3 and the number 4. And you can see 3 times 4 in the iterative version is 12, but 3 times 4 in the recursive version is not correct yet. So that's something we're going to fix here in just a little bit. So I'm going to come up here to multiplication iterative, right? So we said before 3 times 4 is really just 3 plus 3 plus 3 plus 3, right? Which is just a loop. So all I did here in this one is I set my product to 0, and I loop from 1 to whatever this one is, right? I'm going to take this number, add it this many times. So I'm going to take 3 and add it 4 times. So that's what I'm going to do here. I'm going to loop 4 times, and I'm simply going to just simply add that number 3 back into it over and over again, which is going to give me 12. All right, now what I want to take a look at, this is the part that's a little bit kind of a tough thing for some people to grasp. Okay, so we're going to talk about something recursively, right? So really, we're going to say 3 times 4 is really the same thing as saying 3 plus 3 times 3, right? Because 3 times 3 is 9, plus 3 is 12. But what is 3 times 3? 3 times 3 is really 3 plus 3 times 2. And what is 3 times 2? It's really 3 plus 3 times 1. And what is 3 times 1? It's really 3 plus 3 times 0. And what is 3 times 0? 0. So this is called recursion, where I'm going to take my multiplication function, I'm going to keep calling myself over and over again. But so like we said, 3 times 4 is 3 plus 3 times 3. And 3 times 3 is 3 plus 3 times 2. And 3 times 2 is 3 plus 3 times 1. What is changing in here? If you look, it's the second number is decreasing 1 every single time. The other part is this creates almost like an infinite looping situation, but you have to have what's called an exit. You have to have an exit condition. And the exit condition for me is whenever I multiply by 0, I get 0. So what ends up happening is I say to get 3 times 4, I have to call the 3 times 3. Well, to get 3 times 3, I got to call the 3 times 2. And to get to 3 times 2, I got to call 3 times 1. And to get to 3 times 1, I got to call 3 times 0. But what is 3 times 0? It is 0. So this gets subbed back in here. So 3 plus 0 is 3. So 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. And I got my answer. I don't know if that makes a little bit of sense to you. It'll hopefully start to make a little more sense for you here in a second. So we're going to use this recursive idea. So remember, the key part is is you're going to call yourself, but you're going to deduct 1 from it each time. And you have to have a situation you got to look for. When the second number is 0, my answer has to be 0, right? Because 0 times anything is 0. So let's take a look at the recursive code now. So I'm gonna, right now I just simply have it returning 1. So I'm going to take num1, which would be the 3, or which would be like, we did 3 times 4, right? So I'm going to keep deducting this guy until I get it down to 0. So I want to say, I'm going to take this out right now. If num2 equals 0, I'm going to simply return 0. Because remember, anything times 0 is 0. Else, what did we say we had to do? We had to reduce number 2 by 1, right? Remember we said over here that 3 times 4 is really 3 plus 3 times 3. So that's what I'm going to do here. I'm going to simply say return. That happened. Say return. We're going to take the first number, right? Remember it was 3 plus, right? So in this case, that 3 is the first number, plus multiplication. I'm calling myself recursion, or not recursive, sorry, num1, so I'm calling myself 3, but I got to reduce the second number by 1. I'm going to come to the end here, put a semicolon, and I'm going to put end of else. So again, multiplication recursive. I'm going to take this number times this number, but what I got to do is I'm really going to take this number plus these two numbers multiplied together with this guy reducing by 1, right? So we said keep going until I get down to 0, and I'm going to return 0. So there it is, right here. I said if my second number is 0, I return 0. Otherwise, if it's any other number, I'm going to take the first number plus the multiplication of the first number and 1 less of the second number, which is exactly what we were doing here. 3 times 3 is really 3 plus 3 times 2, and 3 times 2 is really 3 plus 3 times 1. So we're just reducing that second number by 1 each time. Okay, so let's come back over. Let's go ahead and let's run this guy. And let's go full screen here. So now when I say number 1, I say 3 and 4, they both tell me 12. If I choose number 1 and I say 5 and 7, they both should tell me 35. And if I say number 1 and I say 5 and 0, they tell me 0. And if I say number 1, if I say 0 and 5, they still come with a 0. If I say number 1 and I say 99 and 2, I get 198. And if I say number 1, I say 2 and 99, I get 198. So it's working out. It actually is doing the work for you, and it's working correctly. Okay. So the next piece then I want to take a look at is we've talked about multiplication. How about this one we've done? We've done powers, right? So 3 to the 4th power is really 3 times 3 times 3 times 3, right? So when I come back to this program, I'm going to minimize this guy, I have an iterative version of powers. So I'm going to take the base and the exponent. And if you look, I'm going to set my power to 1, right? Because if you raise anything to the 0 power is 1, right? And I'm going to loop the second one. I'm going to go from 1 all the way up to whatever the exponent is. So let's say I do 3 to the 4th power. I want this to run 4 times. So I say my power is really equal to my base times my power, right? So the first time, let's say I did 3 to the 4th power, it's going to be 3 times 1, which is 3. And then the next time it's going to be 3 times 3. And then the next time it's going to be 3 times 3 times 3, right? And so forth. It's going to keep on looping, and it's going to return power for me. So I'm going to go ahead and run this. And when I choose number 2 for power, and I say 2 to the 3rd power, which is 8. Okay, but notice on the second one it didn't work. And if I choose 2 and I say 3 to the 4th power, it is 81, right? If I were to say 3 to the 1 power, that should be 3, correct? oh, I hit the wrong thing. Sorry. Number 2, I'm going to do 3 to the first power is 3. And if I choose number 2 and I say 3 to the 0 power, it should be 1. Okay, so that's what we're going to fix right now. We're going to look at this from a recursive standpoint, right? So recursion, just like we did with multiplication, we're really going to just say 3 to the 4th is really the same thing as saying 3 plus 3 to the 3rd. Not plus, that was supposed to be times. I'm sorry about that. I should say times. We're going to see that problem in this whole thing. And what is 3 times 3 to the 3rd? Or what is 3 to the 3rd? It's really 3 times 3 to the 2nd. And 3 to the 2nd is really 3 times 3 to the 1st. And what is 3 to the 1st? It's really 3 times 3 to the 0. And what is anything raised to the 0 power? It's 1. So again, if you look, what did we do? This guy's looping, but this guy's using recursion. He's going to keep calling itself. I'm going to take my power method. I'm going to take this number and multiply it by itself raised to 1 less, right? Instead of 4, it's going to be 3. Instead of 3, it's going to be 2. Instead of 2, it's going to be 1. But I got to get to a condition that I exit, and anything raised to a 0 power is always 1. So with that in mind, what you're going to need to do is, if I come into power recursive right now, I just have it returning 1. You're going to need to rewrite this and actually make the recursion work for power, or powers work for recursion. And what I would recommend is use the recursive one that I just wrote for you. Use that as a model to help you with this one. All right, the other one we want to take a look at is something called a factorial. And from math class, I hope you remember, 4 factorial is really just 4 times 3 times 2 times 1, right? So you're going to have to write a program called factorial iterative right now, and all it has is return 1. So if I put in the number 4, you're going to write a method that's going to write a loop that's going to multiply 4 times 3 times 2 times 1. If I put in 7, then it'll be 7 times 6 times 5 times 4 all the way down, right? The lowest number you can put in for a factorial is actually 0 factorial. And just so you know, 0 factorial is actually 1. I'm not going to give the explanation for it. I highly recommend go look it up. It's actually kind of a cool idea how they come up with that. But 0 factorial is actually 1. So what I want to look at, though, is the recursive version, right? So the recursive version is always calling itself. So 4 factorial and iterative version just simply loops down. But the recursive version of 4 factorial is really 4 times 3 factorial. Well, what is 3 factorial? It's really 3 times 2 factorial. And what is 2 factorial? It's 2 times 1 factorial. And what is 1 factorial? It's 1 times 0 factorial. And what did I say 0 factorial was? 1. There's my exiting condition. So you're going to need to write a factorial iterative that does it this way with a loop. You have to write a factorial recursion that does it this way, calling itself. Now, I'm not going to get into too much detail on this right now. If you look at my multiplication iterative versus my multiplication recursive, it really is not saving lines of code. The simplicity of it, it's actually really simple to do. And you're going to find out on this coming soon one that I have on here. So when we get to this next week, we're going to talk about one other piece that you're going to add to this program. And you're going to see that doing it iteratively is way more challenging than doing it recursively. And next year, if you take AP Computer Science, you're going to find out that when we get into certain things like searches and sorts, where really writing it recursively is really the only real way to write it. And it'll save you a lot of concept and time. So I expect that some of you guys are a little bit stumped right now with what the heck I'm talking about, and that's okay. What I'm going to do is I'm going to let you guys work on this on Thursday. On Friday, I'm going to set up some office hours for you. And I want you guys to pop in and ask me questions if you're stuck on this. All right. Hope you guys have a good one and have fun doing some programming on this. This is one of my favorite subjects.